So the first step here in the limiting reactant experiment is to just weigh out a blank evaporating dish. So with that, and then I'm going to put the filter paper on it. Okay, so here's just a little glass plate, also known as an evaporating dish, and a filter paper. So we're going to really collect our calcium phosphate on this filter paper. So weighing that, you want to have your data sheet ready and note this in your lab notebook. So the mass of the filter paper and evaporating dish is about 55.52 grams. So I'm going to write that down, 55.52 grams, and put that in my lab notebook. And we're going to collect, as I stated before, the calcium phosphate. In this, we're going to make this into a funnel, and I'll show you how to do that later in the experiment. Let's weigh out our reagents, pour them together, and get our precipitate. All right, so the first thing we will weigh out in terms of our reagents is the calcium nitrate tetrahydrate. So it's the calcium nitrate with 4 water molecules hydrated together. So we're going to weigh out about 1 gram or so of that. So we're going to take what's called a weigh boat, and we're going to weigh the weigh boat in. Okay, I'm going to tare it, and I think here in this scale, that's the tare button. So about 1 gram or so. So whatever you weigh out, make sure you record that exact number in your lab notebook. A little bit more, but I'm going to go with that. 1.23 grams of the calcium nitrate. 1.2, let that settle. Let's go with 1.22. 1.23, 1.22, that's fine. And that's what I'm going to write down in my lab notebook, 1.23 or so grams of the calcium nitrate tetrahydrate, so 1.23 grams. The protocol says 1 gram, but they got a little bit more than 1, which is okay. I'm going to set that aside here. Okay, we're going to mix those reagents a little bit later. In your lab station, you have only 1 spatula, so we can just wash this off and clean it. For this second reagent, let's tare this. This is going to be for our sodium phosphate. Okay, so this is sodium phosphate dodecahydrate. You mix this with the calcium nitrate, you get a calcium phosphate. Again, the 12 waters just means there's 12 water molecules in complex with it. Let's tare this, and we're aiming for about 1 gram also with this reagent. One of these is going to be limiting, one of these is going to be excess, and that's what we need to find out. And hopefully we can get as much calcium phosphate yield as we... Alright, so 1.07, and I am going to 1.05, let's go at 1.05, 1.06 grams of our sodium phosphate dodecahydrate. And now we have that, we have our calcium phosphate. We're going to mix these two together. We're going to make this into a solution. We're going to make the calcium nitrate into a solution. Once they're in a solution, we'll mix both those solutions together. And just because I weighed out a little bit more of the calcium nitrate does not mean it's excess. Okay, we got to do the stoichiometry, we got to do the calculations in order to determine what is limiting and what is excess. Alright, so we weighed out our 1.23 grams of calcium nitrate. Let's put that in here. This is called an Erlenmeyer flask, so I'll let that all go in. You can actually get that other stuff that is stuck in the weigh boat with some water, which is what I'm going to do now. See if we can get all of that reagent that you put in with some water here. Alright, so there's my calcium nitrate. Let's put it into 50 milliliters of water. We will do the same thing with our sodium phosphate as well. So it looks like it went into solution pretty well. But we can heat this up for a little bit. It did go into solution, so it's not really mandatory that you do heat it, but let's just heat it anyways under light heat, maybe level 1 or level 2. And let's do the same thing now for our sodium phosphate. Get anything remnants out there. And this also, the sodium phosphate, make sure these are labeled, so with a wax pencil or something, make sure you know which is which. So labeling is important for this experiment. And 50 mils of water to this. So we got 50 mils of of water in about 1 gram or so of sodium phosphate, the exact amount I have in my notebook. And then here we have calcium nitrate, about 1.23 grams, the exact amount is in my notebook, and 50 mils of water. It's already, looks like by my eye it's already dissolved, but I'm going to let it go in heat for maybe about 5 minutes or so. You just have to have a feel for it, and we will start mixing these two to get our precipitate soon. Alright, so this calcium nitrate, it looks like it's completely dissolved, so I put it in some heat for about 5 minutes or so, very light heat, but it's already all dissolved in. The sodium phosphate, it's a little bit more finicky, so I used a stirring rod to try to get that little last chunk into water, and it's going in, but you may need to stir it and for a certain amount of time before it all goes into solution. So this requires some stirring, maybe a little bit more stirring than the calcium nitrate one. All right, so looking at it by eye. All right, so here's our sodium phosphate, the source of phosphate. Sodium is the counter ion. It's not going to participate in the reaction. Here's our calcium nitrate. Calcium is going to precipitate with the phosphate here to give us calcium phosphate. And the nitrate here is just the spectator ion. So let's mix these two up. The goal here is to maximize the precipitate, maximize the yield of calcium phosphate, which is this white substance here. Alright, so here's our calcium phosphate precipitate. It's in water. We want to isolate this. So we want to try to evaporate some of the excess water here. So we will boil this for about 15 minutes. The protocol says a gentle boil. To many people that means many different things. I have it here on level 2 or level 1 to level 2. You use your best judgment here in terms of gentle boil, and keep the stirring rod in. The stirring rod actually helps, in some strange way, it actually helps facilitate precipitation. So we're going to let this sit here for about 15 or so minutes. I have it on level 2. Again, use your best judgment when you do this in the lab. 2, maybe a little bit less than 2. After 15 minutes, we'll come back and we'll filter this precipitate out. All right, so it's been a little over 25, actually it's been a little over 15 minutes, more on the 20-25 minute side. And I don't know if you can see it here on the via the camera, but I do see a big precipitate, a big chunky precipitate, so we want to collect that. I'm going to go ahead and turn off the heater here, and we'll come back here to this setup here. This is a gravity filtration. If you read the lab manual, they use vacuum filtration. We'll do gravity filtration. We'll let gravity slowly take all the liquid out of the precipitate. That white precipitate is calcium phosphate, by the way, reacting sodium phosphate and calcium nitrate. So here's our Erlenmeyer flask, here's a little glass funnel, here's our filter paper that we laid out at the very beginning of the experiment. So first thing we're going to do is we'll make a funnel, filter funnel. I already folded this by half. All right, so that's 1/2 fold. We'll do a 1/4 fold. Okay, so fold, and then fold it again. And I like to fold it another time. You can even fold it once more. It certainly will not hurt. So I'll go ahead and do that. You just get more lines, more of the striations in the filter paper. So we'll unravel it and put it down here, rest it on the glass funnel. So now to get this filter paper to stick, I like to pour some water in there. That just helps it adhere to the side of the funnel. And you can use your hands here to sort of rest that. Alright, so our calcium phosphate precipitate will rest here, and hopefully all the liquids that contain the spectator ions will go into our filtrate. Alright, so this is still kind of hot here, so you want to take some mittens, hold this here, and very slowly just going to pour it in. Okay, so don't overfill this. That is, don't overfill the filter paper. Okay. And what should stick to the top of the filter paper is your calcium phosphate. What should go in the bottom, which is called the filtrate, is all your ions. The excess reagent should go down here, the ions that remain in solution. That is, the ions that still are dissolved in water. The excess goes down in the filtrate. Here's all our calcium phosphate, white solid, that's going to stick. So. Some mishaps that I've seen happen, the filter paper breaks. Sometimes the filter paper breaks and the precipitate goes through. If that happens, you can talk to me and we can figure something out. But technically the filtrate, which is the bottom, should be clear. And the top of the filter paper should have your white precipitate. Okay, we want to calculate the percent yield of that precipitate. So we're going to let that go. Still got about 50 mils or so. And my filtrate is clear, which is good. So gravity filtration will take a little bit longer. Vacuum filtration should take faster, but we're going to do gravity, or this demonstration will do the gravity filtration. And what I like to do is, what I tell students if they're going to do gravity filtration is I'll let the precipitate sit out overnight even to get all that water to dry out. All right, so the filtrate is going to go out and filter through. It's going to be at the bottom. We're going to test the filtrate. It's going to contain your excess reagents. So let me take some time telling you about this theory. You see calcium phosphate is going to be up on top. Whatever excess reagents, so we had two excess reagents, correct? We had the sodium phosphate excess reagent and we had the calcium nitrate excess reagent. I should say we had two reagents. One is the sodium phosphate reagent, reactant, or the calcium nitrate reactant. So whichever one is excess, remember one of these is excess, one of these is limiting. Whichever one is in excess, whichever one of these two reactants is in excess, it will actually go through and be found in the filtrate. The limiting one limits how much of the calcium phosphate is seen as the white precipitate on top. So we're going to continue to let this go, and then when we come back we will look at the precipitate and test the filtrate to see which one is excess. Whatever we determine is excess, automatically by default the other reactant becomes limiting. Alright, so everything has filtered out. Here's our filtrate, it's colorless. Here is our white precipitate. It's still kind of wet. It has a sort of waxy appearance. So you ought to be very careful here. It is kind of wet. And another issue that students have come with, and I've also done this, is that the filter paper breaks. So you kind of don't want to do that. And I'm just going to unfurl it and let it sit here. So the next day we can weigh this. Hopefully if we leave this out overnight, the rest of the water will evaporate. And then we can weigh by difference the next day. Remember, we already got the weight of the evaporating dish and the filter paper. All right, the last part is determining which is excess and which is limiting. So we have our filtrate here, and we're going to split that into two small beakers. All right, so it doesn't matter, it doesn't have to be 50-50. So we're going to test to see which one is limiting and which one is excess. So here we're going to take one of the filtrate, and we'll add some calcium nitrate solution to it. And sometimes you just have to look at it and You don't see a precipitate there. You may want to let it sit for a while. Okay, let's add the sodium phosphate to this same filtrate. 5 drops or more, 5 to 7, and you can definitely see a white cloudiness in this beaker. So let's take some time to understand what is limiting and what is excess. At least I can see it by my eye. If you can look at it overhead too. Can you see the precipitate, Marissa? All right, you can see that. Maybe hard to see if you perform the lab live. You can definitely see it if you look at it by eye level. And so, well, we took that filtrate, we split it into 2. I added sodium phosphate. Now this contains sodium ion and phosphate ion. And I added it to the filtrate, and we got a precipitate. Now what is that precipitate? That precipitate is calcium phosphate. So the sodium ion is a spectator ion. The phosphate ion is also in here. So the phosphate ion reacted with the calcium ion. Now where did the calcium ion come from? The calcium ion came from the filtrate. So this means that the calcium ion went through the filter paper. Okay, enough of it precipitated with the calcium phosphate. The rest of it came out through the filter paper and into this, the filtrate. So the calcium ion is in here. It reacted with the phosphate ion from the sodium phosphate, giving us calcium phosphate. This means of our 2 reactants, the calcium nitrate, again, the nitrate is not involved in the reaction, but it's the calcium nitrate or the calcium ion that is in excess. So by default, the other reactant, in that case the sodium phosphate, is our limiting reagent. So once again, the sodium phosphate is our limiting reagent. This provided the phosphate. The calcium went through here, so it's in excess, and it's the calcium in the form of calcium nitrate as our limiting reactant. So that's the rationale, that's the logic you want to use in determining what is limiting and what is excess. So once again, the calcium nitrate reactant is our excess, the sodium phosphate is our limiting.